Good morning, my dear senior 3 students. Our lesson today in differential and integral calculus is differentiation of trigonometric functions. First of all, as we talked before, if you have y equals sine x, so dy by dx equal cosine x. If y equal cosine x, then dy by dx equal negative sine x. If y equal tan x, so the first derivative is sec squared x. And the new one, if y equal cotan x, then dy by dx equal negative cosec squared x. Y equals sec x, so dy by dx equals sec x tan x. Y equal cosec x, so dy by dx equal negative cosec x cotan x. Example number 1. Find the first derivative for each of the following. Number 1. Y equal cotan 2x minus 1. Dy by dx of cotan is negative cosec squared 2x minus 1, and derivative of the angle 2x minus 1 is 2, so the final answer is negative 2 cosec squared 2x minus 1. Exercise number 2, y equal sec between bracket 3x plus 5. The derivative of sec is sec tan, so it will be sec 3x plus 5 tan 3x plus 5 times 3, which is mean the derivative of the angle. So the answer is 3 sec 3x plus 5 tan 3x plus 5. Exercise number 3, its derivative will be 4 sec squared x minus, between brackets, derivative of cosec is negative cosec cotan, cosec 3x cotan 3x multiplied by the derivative of the angle, which is 3. So the final answer is 4 sec squared x plus 3 cosec 3x cotan 3x. Exercise number 4. The first derivative of sine x is cosine x, and derivative of sec 4 minus x all power 2 is 2. Sec 4 minus x tan 4 minus x times derivative of the angle is negative 1. So the final answer is cosine x minus 2 sec 4 minus x tan 4 minus x. Number 5. dy by dx equal 4x power 3 minus cosec squared 5x power 3 minus 2 times derivative of the angle is 15x squared, which is mean 4x power 3 minus 15x squared cosec squared 5x 3 minus 2. Exercise number 6. Derivative of 5x squared is 10x minus cosec root x minus 2 cotan root x minus 2 times derivative of the root is 1 over 2 times root x minus 2. And 1 here is derivative of the term inside the root, which is mean derivative of x, it will be 1. So it will be 10x minus cosec root x minus 2 cotan root x minus 2 over 2 root x minus 2. Number 7. dy by dx equal 1 over 3 sec x over 3 tan x over 3 plus 0, which is mean third sec x over 3 tan x over 3. The last one, number 8. dy by dx equal derivative of the fraction is denominator power 2, then derivative of numerator times denominator minus derivative of denominator times numerator, which is mean bottom of the fraction 1 plus cotan x all power 2. Derivative of the numerator is 1 plus cotan x times cosec squared x minus derivative of denominator times numerator, which will be 1 minus cotan x times negative cosec squared x. After taking cosec squared x as common factor, the remainder is 1 plus cotan x plus 1 minus cotan x. So the answer is 2 cosec squared x over 1 plus cotan x all power 2. Example number 2. Find the first derivative of each of the following. Number 1, y equal cosec 3x plus 1 over tan 4x minus 1. This is quotient, so the denominator power 2 will be tan squared 4x minus 1. Derivative of the numerator, derivative cosec 3x plus 1 is negative cosec cotan, which is mean negative cosec 3x plus 1 cotan 3x plus 1 times derivative of the angle, which is mean 3, times the, the denominator, which is tan 4x minus 1, minus derivative of denominator, derivative tan 4x minus 1 is sec squared 4x minus 1 times derivative the inside, which is mean 4, times the numerator cosec 3x plus 1. Bring down the same denominator tan squared 4x minus 1. After simplifying, the first term will be negative 3, tan 4x minus 1 cosec 3x plus 1 cotan 3x plus 1 minus 4 cosec 3x plus 1 sec squared 4x minus 1. Second example, y equals sine cosec 5x power 3. dy by dx, derivative of sine is cosine, and bring down the angle cosec 5x power 3. Derivative of the angle, derivative cosec is negative cosec cotan, so it will be negative cosec 5x power 3 cotan 5x power 3, and derivative of the angle 5x power 3, it will be 15x power 2. Rewriting it, it will be negative 15x squared cosec 5x power 3 cotan 5x power 3 cosine cosec 5x power 3. Exercise number 3. If y equal root 14 minus 5z and z equal cotan 2x, prove that 3 dy by dx minus 10 equals 0 at x equal pi over 8. Since dy by dz equal 1 over 2 times root 14 minus 5z times derivative inside the root, which is negative 5, so it will be negative 5 over 2 root 14 minus 5z. And dz by dx, derivative of cotan is negative cosec squared 2x times derivative of the angle, which is mean 2. To have dy by dx, I will multiply the two expressions dy by dz times dz by dx, which is mean negative 5 over 2 root 14 minus 5z times negative 2 cosec squared 2x. Cancel 2 with 2 and negative multiply be positive 5 cosec squared 2x over 14 minus 5z by substitution and replacing z and writing instead of it cotan 2x. So the answer will be 5 cosec squared 2x over root 14 minus 5 cotan 2x. And then the first derivative 1x equal pi over 8. Pi over 8 in radian equivalent to 180 over 8 in degree. So it will be 5 cosec squared pi over 4 over root 14 minus 5 cotan pi over 4, which is mean 45. So the answer is 10 over 3. Substituting in the required, 3 times 10 over 3 minus 10, gonna be 0. Example number 4. Y equal cosec power nx. Prove that dy by dx plus ny cotan x equals 0. Since y equal cosec power nx, so I can write it in the form cosec x all power n. So to have the first derivative, bring down n, will be n cosec x power n minus 1 times derivative inside, which is mean negative cosec x cotan x. So it will be negative n multiply cosec x by cosec x power n minus 1. We will multiply the same bases, we add their powers, so it will be cosec x all power n and bring down cotan x. So dy by dx, and moving this expression to the left side using the other sign, will be plus n cosec power nx cotan x equals 0. As you took y equal cosec power nx, so I replace cosec power nx and write instead of 8y. So dy by dx plus ny cotan x equals 0. Implicit and parametric differentiation. Example number 1. Find dy by dx for each of the following: x squared plus y squared plus 3x minus 4y equals 1 at the point 1 and 3. So here I have two variables x and y, and I will differentiate them with respect to x. So the derivative of x squared is 2x. Derivative of y squared is 2y dy by dx, because we are going to take the derivative with respect to another variable, which is mean x. Derivative of 3x is 3. Derivative of negative 4y is negative 4 dy by dx, and 1 is constant, its derivative equals 0. Taking dy by dx as common factor, so the remainder 2y minus 4. And moving to x and 3 to the right hand side using the other sign, so dy by dx equal negative 2x minus 3 over 2y minus 4. After substituting by the point 1 and 3, so dy by dx equal negative 5 over 2. Second one, x power 2 plus 4xy minus 3y power 2 minus 2x equal 3 by differentiating with respect to x. So here is 2x. Bring down 4. xy, this is product of two functions. Derivative of first times second plus derivative of second times first. So bring down x. Derivative of y is dy by dx. Bring down y. Derivative of x only is 1. Minus derivative of 3y squared will be 6y dy by dx. Derivative negative 2x is negative 2, and 3 its derivative is 0. 2x plus 4x dy by dx plus 4y minus 6y dy by dx minus 2 equals 0. Taking dy by dx as common factor, so the remainder 4x minus 6y, and the other term is positive 2 minus 4y minus 2x. So dy by dx equal 2 minus 2x minus 4y over 4x minus 6y. It will be, if you take 2 common factor up and down and cancel it, it will be 1 minus x minus 2y over 2x minus 3y. After substituting by the point 3 and 0, so the final answer is negative 1 over 3. Example number 2. Find the measure of the positive angle which the tangent to the curve x power 2 plus y power 2 minus 6x minus 8y plus 17 equals 0 makes with the positive direction of x-axis at the point 1 and 2. First of all, I will make the differentiating with respect to x. So it will be 2x, 2y dy by dx, negative 6, negative 8 dy by dx equals 0. Taking dy by dx as common factor, the remainder is 2y minus 8, and moving negative 6 and 2x to the other side using the other sign, it will be 6 minus 2x. So dy by dx equal 6 minus 2x over 2y minus 8. Taking 2 common factor up and down and cancel it. So dy by dx equal 3 minus x over 1 minus 4. Substituting by the point 1 and 2. So dy by dx equal negative 1. So tan theta equal negative 1. So this angle lies in the second quadrant. So after making 10 minus 1, 1, it will be 45. So the angle is 180 minus 45. It will be 135. Example number 3. Find dy by dx for each of the following. Sine 3y minus cosine 2x equals 0. Sine 3y, its derivative is 3 dy by dx cosine 3y. Cosine minus cosine 2x, derivative of cosine is negative sign, so it will be plus, and derivative to x is 2, so it will be 2 sine 2x. 3 cosine 3y times dy by dx plus 2 sine 2x equals 0. Moving 2 sine 2x to the other side using the other sign, so dy by dx equal negative 2 sine 2x over 3 cosine 3y. Example number 2. Sec 2x plus cotangent y equal xy. By making differentiating with respect to x, so it will be here 2 sec 2x tan 2x negative cosec squared y times dy by dx, and here product of two functions, bring down x, derivative of y is dy by dx, bring down y, derivative of x is 1. assemble the like terms or collect the like terms. So here x dy by dx plus cosec squared y times dy by dx equal 2 sec to x tan to x minus y. So here dy by dx equal 2 sec to x tan to x minus y over between brackets sec plus cosec squared y. Example number 4, y equal y bar 5 minus 1 all bar 8. Prove that dy by dx equal y bar 5 minus 1 over 40 x y bar 4. By making differentiation with respect to y, so dx by dy equal 8, y bar 5 minus 1 all bar 7 times derivative y bar 5, which is mean 5y bar 4. So dx by dy equal 40 y bar 4, y bar 5 minus 1 all bar 6. So dy by dx equal 1 over 40 y bar 4, y bar 5 minus 1 all bar 7. Multiply up and down by y bar 5 minus 1. So it will be y bar 5 minus 1 over 40 y bar 4, and this expression will be y bar 5 minus 1 all bar 8, which is mean 40 y bar 4, and this expression y bar 5 minus 1 all bar 8, which is 8. So I proved this equation. Parametric differentiation. If you have the x coordinate and the y coordinate of the point x and y can be expressed as function in a third variable, which is called the parameter of the two equations. X equal function of t f of t and y equal g of t, another function of t, where the two equations together represent an equation to one curve for all values of t that belong to the common domain of f and g expressed in the parametric form, and every value of t get one point x t y t and all these points from the curve. We deduce that if you have function y equal f of t and x equal g of t are parametric form of the equation to the curve y, where f and g are two differentiable functions with respect to t. So dy by dx equal dy by dt times dt by dx, or dy by dt divided dx by dt. For example, to understand it, find dy by dx for each of the following at the indicated value of t: x equal to a t power 2, y equal a t power 4 at t equal 4. So the first derivative, dx by dt, it will be 4 at. Here y equal a t power 4, the first derivative will be dy by dt equal 4 at power 3. So to have dy by dx, I will make dy by dt divided dx by dt. So it will be 4 at power 3 over 4 at equals t power 2. And this expression when t equal 4 will be 4 power 2, which is mean 60. The second one, y equal to cosine 3x theta. So dx by d theta equals 6 cosine squared theta negative sine theta, which is mean negative 6 sine theta cosine squared theta. Y equal 5 sine power 3 theta. So dy by d theta equal 15 sine power 4, 15 sine power 2 theta times cosine theta, which is mean derivative of sine. So it will be 15 sine squared theta cosine theta. To have dy by dx, you had to do dy by d theta divided dx by d theta, which is mean 15 sine squared cosine theta over negative 6 sine cosine squared theta. 15 over negative 6 will be negative 5 over 2, cross cosine with 1 cosine in the denominator, and sine down and up. So the remainder, negative 5 over 10 sine theta over cosine theta, which is mean tan theta. Dy by dx, when theta equal pi over 4, which is mean 45, so it will be negative 5 over 2, tan 45 will be also negative 5 over 2. Find the derivative of root 5 plus x power 2 with respect to x over x plus 2 at x equal 2. So here put y equal root 5 plus x squared and z equal x over x plus 2. So the required is finding dy by dz at x equal 2. So I will get dy by dx, derivative of y with respect to x is 2x over 2 root 5 plus x squared. Cross 2 through, so it will be x over root 5 plus x power 2. dz by dx, x plus 2 all power 2. Derivative of numerator is 1 times denominator x plus 2 minus derivative of denominator is 1 times the numerator x, which is mean x, cross x with negative x. So dz by dx equal 2 over x plus 2 all power 2. So here dy by dz equal dy by dx divided dz by dx. So dy by dz equal x over root 5 plus x power 2 divided 2 over x plus 2 all power 2. And after simplifying, the final answer will be x times x plus 2 all power 2 over 2 root 5 plus x power 2. Put here x equal 2, so dy by dx will be when x equal dy by dz when x equal 2 will be 16 over 3. Example number 7. Find the value of the parameter t at which the curve x equal 4t power 3 minus 15t power 2 minus 18t plus 4 and y equal 2t power 2 minus 3t plus 7 first has vertical tangent, second has horizontal tangent. Vertical tangent means the slope is undefined, which is mean the denominator equals 0. Horizontal tangent means the slope equals 0, which is mean the numerator equals 0. So the first one, I will get dx by dt. It will be 12t power 2 minus 30t minus 18. dy by dt will be 4t minus 3. To have the slope of the tangent, which means dy by dx, you will make 4t minus 3 divided 12t power 2 minus 30t minus 18. To have the vertical tangent, so the slope is undefined, I will take the numerator 4t. I will take the denominator 12t squared minus 30t minus 18 and put it equal 0 because the slope here is undefined. After simplifying it by dividing by 4, it will be 2t power 2 minus 5t minus 3. Factorization using your calculator or using the brackets, 2t plus 1 2t and t minus 3. Therefore, t equal negative half and t equal 3. The two answers are acceptable, so the curve has vertical tangent at x at t equal negative 1 over 2 and t equal 3. The second case, if the tangent is horizontal, then the slope equals 0, which is mean the numerator 4t minus 3 equals 0, so t equal 3 over 4. So the curve has horizontal tangent at t equal 3 over 4. Thank you, my students.